I need to stop the transcript. Yep, easy busy. Please go ahead. Please do it.
Okay, perfect. So, hello everybody, and welcome to the crash course about space economy, where I want to try, or when I would like to summarize, essentially current state of affairs in space, what's happening, what will come soon, and generally give you the idea what's happening, and you after this you will hopefully understand what's going on in space industry. So yeah, I guess a small introduction is in place. My name is Igor Zacek. I'm architect by training, maker by heart. But currently I'm sitting on too many chairs, I guess, so I'll pick two most important. At my day job, I'm essentially doing technology-driven product development. I'm helping technology companies to innovate and building their products that are utilizing their technology. So thanks to this, I have quite broad scope. I'm quite versed in construction, sustainability, green tech, etc. Well, essentially, I'm generalist covering every aspect of product development in nearly every area of human activity. But most importantly, and especially for this case, I'm the founder of VytahConf, which is space business conference that is focusing on business creation in the Central European region by introducing new players into space industry. And I want to do the same thing with you, to introduce you to space and maybe establish some connections, and we'll see where it goes. It's always good to start with a history. And so yeah, space always appeared in human minds. You know, for example, like from Earth to the Moon, from Jules Verne. So we are talking like 150 years back. However, like the space activity was truly kickstarted in 1957 when Russians launched Sputnik. Even though it was kind of like the military impulse, you know, meaning that anyone who can launch the satellite can also launch the atomic bomb, can dominate the sky essentially. Subsequently, Sputnik was followed by Sputnik 2, and more or less it started kind of like technological tug of war between US and the USSR. Yeah, and we essentially had a massive technological development. You know, just to mention that I think like 36 missions were flown within next 2 years. So massive amount of human activity. Another major breakthrough was achieved by USSR when they launched a major, okay, so sorry for the pun, but Yuri Gagarin, who orbited Earth, and kind of like it reached kind of like the big pinnacle when US landed on the moon in 1969. However, interest in space fizzled quite quickly out. Essentially, after moon program was concluded, you can really see it on NASA's budget or following years. Like you have like massive investment, and suddenly like, oh, nothing till now. And the reason behind it is that the US achieved their technological economical dominance over Russia, and also Russia had quite a big economical problem, essentially leading to decline of USSR. Luckily, the current situation is radically different. Now we are talking about industry where majority of activity is funded privately. We are talking about roughly 75% of money is going from the private sector and coming back to the private sector. And according to many consultancies, it's one of the fastest growing industries currently, with estimated growth rate, like, well, within 10 years, they will double. We already saw something similar happen. It was 10 years, 10 decades ago with the internet. And there are great similarities between kind of like state of internet in 90s and, or maybe late 80s, early 90s, and space industry happening now. So we are talking about ex-military technology that is slowly leaving the academia. Maybe we can draw parallel to ARPANET. In our case, those are rockets and satellites. Then we are, of course, talking about technology field that is suddenly open for technology commercialization, exploitation. Also, it's characterized by rapid cost reduction. For example, like if we are in internet case, if we are comparing like renting physical copy of movie in comparison to just streaming it to your home. And of course, like one of the characterization is presence of the multiple unicorns, which means companies with over billion US dollars valuation. So in terms of Google, like Amazon, Google, in terms of internet, we are talking Amazon, Google, and in terms of space, SpaceX, Blue Origin, Axiom Space. Yeah, probably I can name 15 when I think more about it. But there are still some, but more and more companies are appearing. And when we are talking about internet connectivity price, that was what was kickstarted the internet development. So we see that within more or less 15, 20 years, we are talking thousand-fold decrease in price. This is very similar is happening in a space. We were starting with cost of 1 kilogram launch to low Earth orbit, which was like higher $10,000, and now we are talking about $1,000 per kilogram. So we are talking about what, maybe like 100-fold decrease in price reduction. Of course, price will go down significantly as soon as spaceship Starship will become operational. So we'll see where it goes. And again, we are seeing still very strong parallel with internet. Essentially, we are talking that we are now entering the exponential phase, that we have launch capabilities. We are launching so many satellites that suddenly, well, we are launching multiple times per day and launching multiple satellites per one launch. So it's like massive amount of material and capabilities are going up. So, but maybe let's talk about rockets, because rockets are enablers in space. They are essentially opening the area and lowering the price of access. So it's very comparable to it's infrastructure layer essentially, and they are comparable to to building data centers for or laying cables and fiber optics for internet. So with proper infrastructure in place, we can start building new economy. And rockets are being built, new types are coming essentially on a yearly basis. So it's a a lot of things are happening in this area. And so yeah, if you are curious how it will look like, let's jump to the next slide. So again, another parallel, this time with colonization of America, the space economy will be very similar to kind of like economy which were during the colonization of America. First, massive traffic between essentially to the space, the big logistical push to the space to develop some infrastructure, but ultimately we will create new industrial powerhouse up there, same or similarly as US became major industrial power after a Second World War. So, but that's maybe very far in the future. So maybe let's talk about like what is space and what can be done in space, and about essentially all the quirks which are there. Now I'm talking about, I'm now doing gross oversimplification. So bear that in mind, that we can characterize space by maybe 3 interesting topics or 3 interesting areas. Like it's a great vantage point, which can be used for satellite communication or for observation. Then, of course, we are in zero-G environment, so it's amazing for in space manufacturing. Of course, it's a very extreme environment, and these extreme are enabling us to break the limits, essentially. So let's break it down in a bit more detail. So essentially, we are talking about high vantage point. We are talking about line of sight communication, better, faster, more secure communication without need for additional infrastructure, no need for pulling the cables, digging ditches, and etc. We have just satellites flying around. So, having Starlink, if you're a Starlink terminal, you just need some small solar panel and you can have internet in the wilderness. Then we are also talking about Earth observation satellites which are 24/7 monitoring the Earth. for example, weather forecasts, but also because there are new technologies, new sensors are being developed and giving us the new capabilities in the orbit. There are constantly new areas which are being opened. We can monitor a wide range of things. For example, monitor fisheries, how many fish are there. We can track fishing vessels. Also, we can track fishing vessels with their radio beacon switched off. Or we can monitor methane emissions, which means that we can see where there are illegal dumps or which country is essentially breaking Kyoto Protocol. And what's more important, because we have satellites up there which are constantly monitoring, we can monitor consistently on a global scale with pinpoint accuracy. Again, when we are in zero G, it's very interesting that in zero G, there are multiple phenomena. Multiple phenomena that are hampering terrestrial manufacturing are switched off, essentially on macro or on atomic level. There are no buoyancy or sedimentation. There is no container interaction. Hydrostatic pressure within liquids it's not present. Thermal convection is very, very different or nearly no present. That means that we can build or we can mix new materials without kind of like fearing that they are separating, they will separate, or we can mix it more properly. We can grow tissues without scaffold, or we can develop completely new materials with unmatched purity or new crystalline structures. Essentially, the material science is becoming a bit easier. For example, there is one great use case. It's called Z-Blend. It's a high purity optical fiber that is so pure that I think it does not require many repeaters for atelectic crossing. I think we are talking like 100-fold reduction in number of repeaters on a cable. So amazing. And of course, we are not mentioning that we are in deep vacuum where there is no vibrations, and essentially we have free energy in hand. And of course, like these extreme space conditions as radiation, large vibrations, extreme temperatures are forcing us to being innovative and come up with constantly new solutions. For example, if we are developing a new CO2 scrubbers for space station, those technologies can be efficiently used for on Earth. Or if we want to grow plants on space stations, that is essentially leading to better agriculture on Earth. And of course, when we are talking about this kind of like how this extreme environment is innovative, like maybe 20 years ago, satellites were sizes of bus or the cars, and now we can reach the similar capabilities with CubeSats, which are kind of like shoebox-sized satellites. So we are talking about, for the price of one big bus, you can have whole fleet of satellites with same capabilities. Yeah, that's something which is multiplying our capabilities. And since I already touched the topic of sustainability space, I would like to also kind of dig deeper into this. Pardon, I will refresh myself. And as the number of launch numbers is increasing, also the number of objects in space is increasing, and I'm kind of afraid that we don't have sufficient understanding of the environmental impact of these kind of activities. For example, we don't understand behavior of a higher atmosphere, which will be essentially daily punctured by rockets. We lack understanding of many activities which is related to space. However, I think this is applicable to nearly any activity on a global scale. Okay, there are some already measurable negative impacts showing up. Rocket launches are essentially controlled explosions, so they are quite disruptive for their environment. Also, a lot of satellites or satellite fleets like Starlinks are equally confusing astronomers and birds. Space debris, you name it. However, I'm not saying we should stop this activity. There are also many benefits, which I'm covering on the next slide. So on this picture, it's planet Venus. It's a literal hellhole. We are talking about temperatures over 400 degrees, which are sufficient to melt lead. We are talking about 90 times denser atmosphere than Earth. there is sulfuric acid rain, and that's thanks to runaway greenhouse effect. And at the very, very beginning, Earth and Venus had a very similar starting conditions. And thanks to this knowledge, thanks to space exploration, we are starting to understand our climate change on a global scale. But also there are different areas of space activities which are either supporting climate change mitigation or having positive impact. For example, yeah, we covered Earth observation, but since the satellites are monitoring greenhouse emissions, deforestation, ice melts, sea level rise, temperature changes, we are creating a huge data set which can help scientists to track the trends and also politicians to create informed policies to essentially implement reduction and environmental protection. Then, of course, we are talking about improved efficiency, batteries, solar panels, new lightweight materials. These advancements are in development are essentially supporting transition from the fossil fuels to sustainable energy sources. But also there is kind of like a huge ultimate space goals. We can build fleet satellites which are essentially capturing the sunlight and beaming it for microwaves directly to the Earth. So we essentially can use energy without power lines, without power stations. So essentially very, very low alternative to carbon fuels without kind of like physical imprint on the planet Earth. And of course, space-based systems can help us to predict and respond to natural disasters, climate change, caused by climate change, for example, hurricanes, flood, wildfires. So early warning and monitoring helps us to be prepared better to reduce environmental and economical impacts. But yeah, will it be sufficient? Yeah, I'm kind of afraid that we need something radical to mitigate the climate change. For example, there are talks about geoengineering the Earth atmosphere, essentially releasing sulfides into high atmosphere to change albedo, to reduce the amount of sunlight coming to Earth, just to slower the heating atmosphere. It's called availing, and it's an interesting technology. But again, it's tackling the same problems as, for example, that we do, as a rockets, that we don't understand what's happening in higher layers of atmosphere. And I think before we implement this, because this is non-reversible, we need to assess this part properly. However, I believe that space tech is our ultimate weapon against climate change. And maybe kind of like to give kind of like the big idea, we can build a huge sail. Essentially, it's very, very thin, a few microns film foil, which we can place between Earth and Sun, and which will shade or reduce heating of Earth. We are talking essentially about just reducing sunlight by maybe 1%. It will be invisible to the naked eye, but it will have less light on Earth. And what's beautiful is that it's reversible in comparison to geoengineering. And what's also beautiful that it's within our informational capabilities. We know it was already done on a smaller scale. It's within our technological capabilities. There were demonstrators flying already in space for a long time, and also in budgetary capabilities. The price for such mission is, last time I checked, was in the lower billions of US dollars. And when we are comparing this to for example, the damages after hurricanes, Hurricane Katrina was $125 billion for one hurricane season. So yeah, I think there is a problem of will, and I believe we as a humanity, we have the will to change it. I think that's the reason why we're on this seminar, to learn about new industry and connection to sustainability. So yeah, and at the end, I would like to kind of like introduce you to VytahConf, which is kind of like my conference, and it's an event designed around idea to build relationships, essentially to bring new people from outside to space industry, and it's designed in a way that during one day event you can get deep understanding of what's happening there, and you can essentially meet top leaders. And when we are talking about top leaders, we are talking, for example, like Rafael. He was SpaceX early investor into SpaceX. Guillermo is like really senior entrepreneur. Essentially, he has fingers in everything what happened in space in the last 20 years. Johannes, white hackers hacking satellites, or of course people like Kelly Wiener-Smith, which is like New York Times bestseller author, and she made a book about colonization of Mars, and yeah, so there are really big names present, and for you is essentially to gain knowledge, to establish personal connections, and explore and understand what space. And of course, it's a great party in a great location in Slovakia, in Bratislava. So you are more or less invited, and if you want to join, just drop me a line, and I guess that's all from my side. Thanks for having me here.
Yeah, thanks, Igor, very much for this presentation. It was a really interesting one. I don't really like get to hear about the space industry all that much, like either in my work or like my previous studies or anything. So that was really interesting. Yeah, I would like to open up the discussion and like the Q&A section of this workshop now. So if anyone has any questions, just raise your hand. Yeah, timer.
Thanks, Igor, for this very interesting presentation. Actually, at the beginning of the presentation, I thought that the space can help us to observe the Earth,
Yes.
like give us a notes about is I going in the good direction or bad direction. However, in the end of the presentation, you start to put some solution, like maybe the space industry can help us really not just observe, but can provide some solution. How much we are far from this application of such solution? Is it applicable within a year from now, 10 year, 100 year?
You know, it's a question of budget. I think that because it's not, to be honest, it's not cheap solutions. As I mentioned, it's lower billions of dollars. And till now, I think the biggest, and I'm talking from the layman perspective of climate change problem mitigations. What I understood is that the problem is that, okay, who's going to pay for the bill? That, for example, if US is paying for the mission, the rest of the world is more or less freeloading. So who is going to pay for this? And even though it's we have technology, there we have already tested the prototypes, and we are more or less technologically, or if we gave money to certain subject, for example, as NASA or ESA, it can be done. But the problem is the will. Like, do we want to do it right now for this kind of price, or shall we wait 80 years till it's much more pronounced climate change, and suddenly like, oh yeah, yeah. So it's not technical problem. I think it's problem of policy and free will and diplomacy.
Yeah, for me, like the...
Rory,
go ahead.
No, I was just going to quickly say, first of all, yeah, massive thank you. It was such an interesting presentation. Lots of kind of new content in there.
Happy to hear that.
Some of the stuff that you were talking about at the end was really interesting there, because I think I've sort of, within the space tech area, I've probably been more exposed to some of that climate adaptation stuff. So in terms of the monitoring and how space tech can be used in that sense, how satellite data can, etc. But in terms of the actual climate mitigation, it's something that I'm less aware of within space tech. So it's interesting to hear things are happening in that space. I guess a question from me would be, to what extent do you feel this is the climate aspect, and particularly that climate mitigation as opposed to the adaptation, is that, how much is that a priority within the space tech sector? Is it something, so I mean, you said it's budget, it's will, it's politics, etc. Is it something that is being pushed by the mainstream, or is it something that's more fringe?
Currently, it's quite fringe, but let me draw a parallel to maybe US after Russia launched Gagarin. That essentially, before that, space flight was very fringe section of NASA, which is like National Aeronautics and Space, and with emphasis that time on aeronautics. And after that, essentially, Kennedy committed monumental national resources to tackling this problem, and suddenly it came from fringe to more or less mainstream. And when people and within 10 years they were able to develop technology and infrastructure to support this kind of endeavor. So I think it's within our technical possibilities, but we are not there yet. We need to develop probably in-orbit manufacturing capabilities, which there are startups which are already doing in-orbit manufacturing of different materials, but not in scale. So
yeah,
we are creeping there, but money is the energy which makes us faster. So that's essentially basic economic activity. More money, faster it goes.
Makes sense. And if you don't mind, Dominica, I have one follow-up question actually, which is very tied to your last comment, which is, of course, that I think space tech is probably inherently hugely capital intensive because of it's space. How accessible is it for startups and for new entrants? Is it sort of massively reliant on public funding and grants to enter this world? What are some of those kind of key barriers?
Mm-hmm. Yeah, so essentially we are talking about barriers to entry for, I think it would be wise to kind of like divide it into maybe 2 or 3 different categories. First one would become like, you can be startup focusing on Earth observation, and your barrier to entry is just like having laptop or computer and having know-how how to kind of like process the satellite images. So this is kind of like low-hanging fruit. If we are talking about and of course, infrastructure for this is in place because, European Space Agency has a fleet of Earth observation satellites which are offering free data for every European company. So it's like we have amazing resource, and if you want to play with it, there is plethora of data which you can just toy and create with some solutions, maybe for banks, insurances, whatever. There, imagination is the limit, or sky is the limit, literally. But if we are talking about connection to hardware, for example, you can do some new materials development for rocket engines that can be done in space. But if we are talking like higher and higher and higher, it's more capital intensive because people are very, very cautious. Like you need to flight test essentially every aspect of satellite, and it's still a very, very cautious approach. And now people are, for example, SpaceX with Starlink is kind of like showcasing. Okay, it's a very bad example to give you the like massive corporation, but they're changing the logic of the industry. They're, for example, in their satellites, they're using a lot of technologies which are essentially common on the ground. For example, like a mobile chip processor is used in a satellite instead of kind of like heritage, very expensive space optimized satellites. Okay, they have higher failure rates, but because the price is cheaper, they can outproduce essentially their failure rate. So it's kind of like something like, and implement the economy of scale. And if we are talking about kind of like developing new solutions, like, okay, are they capital intensive? Yes, they are. But if you are smart, that suddenly looking from for technologies which are outside of space industry or outside of the heritage space industry, you can reduce your price quite significantly. That's the reason why I also have VytahConf, that it's always both ways. Like companies which have some capabilities outside of space industry can go to space industry and help and create something new, and vice versa. And about financing, there are several levels. A lot of already kind of like space investment environment is quite mature, not very present, or it's slower than, for example, Europe, but in US it's quite vibrant, and they are used to kind of like heavy capital intensive startups. For example, like their just seed rounds are in level of millions, which are unheard in terms of software. But also the investors really want to see kind of like alignment maybe with some strategies of European Space Union or European Space Agency, because if you are aligned with some strategy, then you can apply for some funding and it will ease the financial burden for the first startup. Yeah, because they will get kind of like their first client will be European Space Agency, which is, to be honest, good client who is always paying the bills.
Yeah. Okay, perfect. That's really helpful to get that additional context. So thank you very much. And also, I just want to say sorry, my camera's off. I've been having problems with the Teams. But
No
yeah,
worries.
it's really interesting stuff. Thank you very much.
Yeah, Teams is a strange one. Yeah, I would like to ask, because I was kind of intrigued by kind of one of the last points that you had about kind of the like the transparent thing, like in front of the sun or something to mitigate the temperature, and you said that it's already been done small scale. So what kind of small scale pilots have been done?
For example, like if we are talking very rudimentary level, I think it was during the Apollo-Soyuz flight, Apollo spacecraft, during the mission, they used Soyuz spacecraft to kind of like place it in between sun and their kind of like receptacle or some optical sensor, and they were essentially measuring the reduction of the solar influx. So very, very rudimentary, but also we are talking about kind of like looking at the different objects. For example, if you have moon going in front of the sun, how much reduction of sunlight we have on Earth. And if you place something small and significantly far away or further away, you won't see the object because it's just too small. It's like beyond your kind of like beyond your eyes capability to distinguish the object. And of course, it's a direct sun, so nobody's advised to look in the direct sun. But if we are talking kind of like also like if we can produce it, technology is there. We are flying the prototypes there. So we already flew some prototypes of solar sails, and those things are just, even though they are very small, there are CubeSats, they can unfold to several meters wide area, and that's the concept. And because it's the sail is just very few microns thick, it's not that much. We don't need that much material. Of course, we are talking, I think the diameter is like 100 kilometers, but if we have proper infrastructure in space, we can do it. It's not sci-fi. It was done on a smaller scale, very small scale. Let's put it this way.
Yeah. Okay, but yeah, that's interesting. I also am wondering, it's kind of like a side note more thing. Wow, how you came up with a name for a conference? Because for those that don't know, VytahConf, Vytah is like an elevator in Slovak. So why is it called that?
Yeah. Well, when we're establishing conference, we're looking for kind of like uplifting names, like Startup Accelerator and something else. And so we were, of course, naturally looking around ourselves, and we saw elevator, and like, oh yeah, that's perfect. Like elevator, it goes up, and also there is a space connection, because there is one concept of kind of like very cheap transportation, or very carbon low carbon transportation system, which is called space elevator. Essentially, put tether into space, and then you have essentially elevator going up, which is way beyond our technological capabilities now. But it can be, for example, done on the moon because the gravity is lower. But so yeah, we like, oh yeah, this is amazing name, but also like because it started as a volunteer conference, then we felt like, okay, but the elevator is also going down, so we have kind of like the plausible deniability is something goes wrong. So yeah, it was, you know, very not very serious naming effort. Let's put it this way.
But yeah, I like that. I like that philosophy behind the name. Tamer?
Actually, I have a not question invitation for you, Igor, linked to the conference. We at our initiative we are organizing something called Clouders Eye Conference, and it's actually moved between our partner institutes. And the next conference will be in June, from 9 to 11 June 2025, and it will be in Poland. And in this conference, actually, we invite brilliant people as you. We invite business, we invite students, academic, and policymaker to come together and try to give examples of innovation, success story, and so on. So I hope if you accept our invitation to attend our conference next year. And maybe actually we was in discussion with G4 since some time to host the conference in Slovakia, maybe in 2 years or so. And it would be great if we can just come together and organize something together with you in Slovakia.
Mm. Yeah, we are. Yeah. First of all, thank you very much for brilliance. Like, I doubt, but okay. But thank you very much for the invitation. Like, please send me some information. There was my email. Dominic has my email, so I'm definitely open for this kind of events because it's always great to meet new people and kind of like extend your horizons. And of course, like, you know, in Slovakia, we have ready event team, which is quite capable. And I'm definitely open for any kind of cooperation also in this kind of thing that we can do something in Slovakia. Perfect.
Yeah, that's great. I'm just thinking where in Poland it is. I think Poznan, but I'm not sure now. Anyway, yeah, we'll send you the information.
Yeah, I will send the information. Actually, I didn't remember the name of the city.
Yeah, it also just slipped my mind right now. Anyway, does anyone else have a question that they would like to pose to Igor about the space or anything?
You know, guys, or if you just tell me your kind of like background, I can maybe give you some hints or tell you more from perspective of space or your industry, what's happening closer to your expertise. You know, I'm here. I'm ready to talk. So don't be afraid, or not.
An AI student.
Yeah, Noor.
Yeah, I mean, I don't know. I'm also just wondering what kind of opportunities are there for students in terms of like getting into the space industry. If you kind of know about some internship opportunities in that area, or kind of where to start if you want to get into this.
Like getting it, like maybe not even for students, but for everybody. Let's broader a bit. Let's make it a bit broader at the beginning, because space is growing so much that suddenly there are not enough people with kind of like space heritage, education and experience, and so therefore kind of like people from outside of the industry are really attractive as a workforce, and so if we are talking like maybe lawyers, space law is still very rudimentary legal system based on our kind of like maritime law, but it's because it's developing so fast. We have for example, specialized law companies are appearing, already appearing, or specialized investment companies, or this. So law, or maybe some engineering guys. It's already so big demand for certain skill sets that that yeah, there. I don't want to say there is nearly no limit, but you need to find your proper avenue how to enter. For example, we started VytahConf because I'm architect, and what architect can do in the space industry, and I always wanted to do something in space. Like, yeah, first I need to meet people and understand what's going on. So I started the conference, and this is the way how I develop kind of like a certain know-how, and suddenly is a vessel how I'm, or is a way how I'm working in the space industry. But what I recommend to students, like, find someone within your kind of like area of expertise. For example, if we are talking about maybe agriculture, there are multiple startups which are working on kind of like growing plants on Moon, on Mars, which are desperately needed talent. And what's perfect is that it's not just very kind of like hypothetical way of work. For example, there is a company called okay, I don't remember the name, but there is it's a French company. They have a greenhouse which is designed for Mars in close to Paris. But their kind of like business is that they are essentially making better greenhouses at the end. So they are making our agriculture more efficient. So it's always kind of like two-way approach. It's not like we're putting there somewhere and it's lost, but it's always there is direct feedback loop to Earth.
And I'm just also wondering, because you said at the beginning that you kind of work with various startups in terms of like their innovation and everything, and I'm wondering if you're also working with some space tech startups in this regard, or is this more of just like a conference interest?
We are now trying to kind of like launch also kind of like business advisory group within VytahConf, but because it was volunteer organized conference, our kind of like our essentially resources were limited. And because essentially we are just two organizers of quite major conference. It's strange, but two people can organize quite big conference, and with small kids, and we are guys with small kids, so our time was limited. But now, when our kids will be bigger, we'll also try to extend our capabilities within the area. Like, okay, we'll try to help space startups and space companies to develop something, and especially like within my kind of like day job, kind of like taking technology and creating and commercializing it. That's perfect field to be in.
Yeah, absolutely. Well, I don't know, in case that no one else has questions, yeah, this is your last chance, I think, to ask questions. So if not, I'm gonna thank you very much for your time, Igor. It's been really, really interesting. And yeah, I'm looking forward to kind of seeing where this whole thing goes. I don't know, also in terms of kind of the recent elections and everything, I feel like the support for the space might kind of be skyrocketing. It's the word that came into my mind. So yeah, exactly. So I'm kind of interested to see how that goes, but I think we'll be hearing a lot about that, and very a lot of like contested points politically as well. So
yeah. So Dominic, as you mentioned, like we'll be hearing a lot about space because it's just massively growing industry, and I believe because like political climate, we are at the beginning of kind of like a new space race, kind of like new West and East, and especially like Western world versus China. They are quite two big contenders. Yeah, but not to talk more. Like, guys, thank you very much for kind of like having me here. It was always kind of like, it was a pleasure, and thank you for actually very good questions. And if you want to know more about space, or if you are curious, or just questions, like, do not hesitate to contact me. Probably reach out to Dominika for email, but I'm happy to kind of like help you with kind of like onboarding to space industry, or to connect you to somebody. It's this is what I do, so don't hesitate to reach out, and I will try to help you within VytahConf.
Yeah, thank you so much for the offer. That's really great. We appreciate that. Yeah, so best of luck to you, and yeah, I'll talk to you soon probably.
Perfect.
Yeah,
Okay, guys.
yeah.
Cheers. Have a great
Have a
day.
nice day, everyone. Bye.
Bye.